Hi everyone. In this video I want to talk about long and wide data formats. First I'll make a data set. So I'm just going to take like the male Harrys and the female Hermiones from baby names, and I'll filter for year greater or equal than 1980, and then I'll select year name n. It doesn't really matter how I got this data set. That's what it is, and what you see is that in the 80s there weren't actually any Hermiones, and then in 2001 there's 5, and then 17, and then 59, and so on. So it seems like the Harry Potter books did have some influence here. Okay, so this data frame is in what's known as the long data format. It's kind of the same as the tidy data format. So that means that there is one measurement per row. So for example, for Harry in 1990, we measured this much. And then for Harry in 1995, we measured this much, and so on. So this is in contradistinction to the wide format, which is not like that. So first, let's see, because I think it's kind of hard, if you're looking at this data frame, it's kind of hard to imagine like what other format could there be. So let me create the wide version of this. So we'll view wide. And this looks like that. Okay, so we'll look at the syntax in a second. So here what's happening is for 1880 we have this many Harrys and there's no Hermiones, so it's NA. So we could change it to a 0 if we really wanted to. And then for 2001 we have this many Harrys and this many Hermiones. And what you see is that now for each row we actually have two measurements, right? So we have one for Harry, and well, so here you don't have any for Hermione, but like here you have one for Harry and one for Hermione. So that's a wide format because you have more than one measurement per row, and some stuff is, so kind of Harry Hermione used to be a column, and now we just have like one column for Harry's and one column for Hermione's. Okay, so how do we get that? So we started from B, which was in long format, and we said pivot wider, and then we said we want the values, so the measurements, we want them from column n. Okay, and then we want the names, so those would be the new columns. So kind of we'll look at the column name in B, so this one, and then we'll say, well, kind of each separate category here, so Harry and Hermione are now going to be their own columns. And then for Harry, we'll kind of, for 19 Harry, we'll look up this one. There's no Hermione, sorry. So for 2001, for Harry, we'll look up this, and for 2001 Hermione, we'll look up this, and then this and this number are now going to be in the same row, and there's going to be two columns, one Harry, one Hermione, because those are the only options in the column name, right? And here we said we take the names, so this is the names of the new columns in the wide format. That's taken from the column name, and then the values, so the values in those new columns that are Harry and Hermione, those are coming from n. And we get this wide format data. So we can also convert from wide back to long, right? So here we'll say wide, and then we'll do pivot longer, and we'll say collect all the data from those two columns, so from the column named Harry and from the column named Hermione, collect all of this data, so this stuff and this stuff, right? And and now put the values that you collected from those columns in the wide data into the new column n, and then Harry and Hermione are going to populate this new column name. So this is just us going back to what we used to have, right? So if I do long like this, I can view long, and I get this kind of thing. So the only difference is now we also have the NAs that we actually created when we went from the original data frame, which was missing the data for Hermione 1980 because it was just under 5. So now we have the NA. Okay. So why bother with all of this? Well, sometimes you want to present tabular data, and that's why. But another reason that you might bother with this is that it's much more convenient to plot data using ggplot if it's in long or tidy format, right? Because if you have data that's like that, you can, for example, say, I want one curve for Harry's and one curve for Hermione's, for example, right? So you might say ggplot, and then so let's plot this long, right? And now let's say that we want 2 curves that represent kind of the number of babies. So we'll say geom smooth mapping, and then the year is going to go on the x-axis, and the n is going to go on the y-axis, and then we want 2 curves, one for Harry, one for Hermione, so we'll say color is equal to name, like this. So we have some NAs, so it's complaining a little bit about that. And this is the kind of thing that you get. It's actually Harry's, as you see, actually there's fewer and fewer of them, but there's more Hermione's. Okay, so while we're here, if you wanted to display the zeros here as well, because it's not that the data is missing, is that we had fewer than 5 babies named Hermione there. I hope I did not misspell this. So how might we do it? So here you have this kind of, and actually kind of the data is missing, so it's actually displaying correctly in the sense that the data is missing. But let's say that we want to set the NAs to 0. So to remind you, this is what things look like here, right? So what I can do is I can say, so I can say is an A long $n, and that's going to be false whenever it's not an A, and it's going to be true otherwise. So I can say long $n, and then I'll say is an A. So whenever it's an A, I'll just set it to 0. So this is fine. So this is falses and trues. So now I go long $n, then I go at is an A long $n. So this is all in A's, and then I want to set it to 0, and it's not letting me. So I have a workaround here, so I'll just say A is long n. So now A is like this, and now I'll say A at is an A is 0. So now I replaced all the NAs with 0, and now I'll say log $n is A again. And if I refresh, now I have my zeros. So now if I want to display things again, that's going to be okay. It's now going to display my zeros.